The next formula I want to talk about is the compound interest formula, which is A equals P times parentheses 1 plus R divided by N parentheses to the N times T power, which, if you'll notice, looks a lot like the exponential growth and decay function, but instead of a Y we have a capital A, instead of a lowercase a we have a capital P, and so on. The difference is what's inside the parentheses here, the b value, and in the exponent, instead of just an x, we've got two things going on up there. So let's talk about what each of these means. First, the t, that stands for the number of years. The capital A, that's the amount that you have after t years. P, before we said that was the starting amount. P is basically the starting amount. It's the principal, or how much money you invest at the start. R, lowercase r, is the rate of interest, and N is the number of times per year that interest is compounded, meaning how many times do you add in the interest per year. If it's once, then you just make it a 1. If it's 4 times, you make it a 4. One note about the rate of interest here, you're going to want to take the percent and divide it by 100, and that will give you your rate of interest. So remember up here when we were doing the B, we did 1 plus whatever your percentage was divided by 100. That's the same thing here. You're just going to take that rate of interest, whatever percent it is, and divide it by 100. And that's, you should have a decimal here is what I'm trying to say. So let's do a couple of examples here. Julio invests $6,000 in a savings account while simultaneously purchasing a $55,000 boat. Write a function to model each situation, the value of his savings account after t years if he earns 3.25% interest compounded quarterly, meaning once every 4 years, and B, the value of his boat if it is expected to depreciate by 8% annually and the depreciation is calculated once per month. So I'm going to start with my equation. A equals capital P for the principal, 1 plus R over N to the N times T power. So I don't know A. That's going to be part of the equation because A is going to depend on the number of years, and right now we don't know the number of years. So keep the A in the equation. The P, the starting point, that's your $6,000. You're going to have that 1 plus. Now the R is 3.25%, but we want to divide that by 100. So for my R, I'm going to put 0.0325. That's my R when I divide it by 100. And the N is the number of times that the number of times per year interest is compounded. Now this says this is compounded quarterly, so that means once every 4 times per year, because there are 4 quarters in a year. So that N in this case is a 4. And then to the NT power, so that's going to be to the 4 times T power. And that's it. So A equals 6,000 times 1 plus 0.325 divided by 4 to the 4t power. That is the equation that you could use to calculate the value of his savings account after t years. Let's talk about his boat, because now we're not talking about appreciation. He's not getting more money. His boat, he's put money in his boat and it's depreciating every year. So depreciating means it's losing value. So the key difference here is instead of having a plus, we're going to have a minus. So I'm still going to have the A. The amount he spent on the boat is worth $55,000. That's the starting amount. And we're going to have 1 minus, it's depreciating at 8% annually, so that's going to be 0.08, or 8 divided by 100 is 0.08, divided by, depreciation is calculated once per month. That's 12 times in a year, so I'm going to divide this by 12. And then up in the exponent there, that's going to be 12 times t. So that's the equation that we would use to calculate depreciation. So it's the same idea, it's just if it's losing value, you're going to do 1 minus instead of 1 plus. Okay, last one. Suppose you invest $1,400 in a certificate of deposit, a CD, which earns 2.25% interest compounded twice per year. How much money will you have when the CD reaches maturity in 10 years? Let's start with writing the equation. A equals the starting amount, which is $1,400, times, now this is going to gain money, so I'm going to do 1 plus the rate divided by 100 is 0.0225, and it's compounded twice per year, so I'm going to divide everything by 2 there, and it's going to be 2 times t. Well, we know the number of years this time. We know t. That's going to be 2 times 10, or just 20 if you prefer. So at this point, it's calculator work, and let me show you how to type all this into the calculator. Okay. So let's start with the 1,400 times, and now we've got some parentheses here. I'm going to use just one parentheses for now, but I'm going to use another one in a moment. So I'm going to do 1 plus that 0.0225 divided by the number of times it's compounded per year, which was 2. So divide that by 2, and see how I put that everything after the 1 plus in parentheses, so I need to close the parentheses twice here. Now I need to raise this to the power of, and I always put my exponent in parentheses, so raise it to the power of 2 times 10, or you can just type 20 there, it's the same thing. So when I hit enter here, I should know the amount that he's going to have after the 10 years of maturity. And it looks like he's going to have, or not he, but you, sorry, the amount is going to be $1,751.05. And don't forget your units there, so you'd want the dollar sign. So you're going to want to round to down to the nearest cent. That's how usually investments work. They're not going to round in your favor. So if this was 0.055 or something like that, you'd still round down to 5 cents. You're not usually the bank rounds in its favor. So after the 10 years of maturity, that $1,400 would turn into $1,751. All right, that's it. Thanks for watching.